Okay, next up, ATM Insecurities by Vladan Nikolic. Enjoy.
Thank you, and hello everyone. So today we are going to cover one, I hope, to be interesting topic. It will be a bit complex and we don't have too much time, so I will try not to speed up, but if you have any questions, we can discuss this later. I will be around for today, during the day for sure, maybe tomorrow. So if you have any questions, please don't hesitate to interrupt me as we go, okay? So a little bit about me. So you know my name, Vladan, and I'm a retro computing fan. That is my primary daily job. So I enjoy old computers, and in my spare time I also work for IBM as X4-Thread security consultant covering EU countries. And last one I think I should remove because it is kind of assumed for everybody who is doing anything related to IT or security that goes as given. So, and for everybody, we have tonight Rakia League, so I hope you will be there and to see what we can do about the last point. And what I'm going to discuss today. So I'm not going to discuss much, but something that is very common in our daily lives. It's ATM machines that we love very much because they give us money. And we hate them because sometimes they say, you know, you don't have money. And we don't like them that way, but they are there, and we use them very commonly, we interact with them. And the question is, are they secure enough? So that's always the question, because what you can do if you have a safe full of money positioned somewhere outside on the field. So it is very interesting target for attackers. Okay, so, and it is very complex to protect such a target from those attackers, because amount of money in them is usually very good motivator for bad people to come and see what they can do. And they can do a lot of stuff. But first question is, what is actually ATM? So we see it is an enclosure, we put our payment card and we get money, yay. But what is actually hiding inside? So I believe most of you are aware that there is just a standard PC inside that enclosure with few attachments. The most important attachment and most interesting one is money storage with dispenser. Then we have card reader, receipt printer, keyboard, screen, cameras. There can be some other additional things, but these are the main ones. So they are all put in enclosure and connected together in order to function as a whole. So all these attachments are usually connected nowadays via USB port. So there is nothing specific, nothing special, nothing dedicated. Standard USB ports are used to connect everything and to communicate. And of course, there is also a network connectivity, which is done using mostly off-the-shelf parts. Being routers, if it is in the integrated network, or if it is somewhere where you don't have your standard network, then it's some kind of wireless, 5G, 4G modems, or whatever. So we saw, for example, if they are positioned in the malls, they are using existing network which is shared by all others users of the mall, and we just hope they do use any VPN, which might or might not be the case. So yeah, these are real ATMs. So some stuff are blocked because I don't want to reveal, because nobody wants to actually lend me an ATM machine so I can play with it. I don't know why, but it would be really nice of them, but nobody wants to do that. So in addition to these hardware components, there is of course a software component, because I said it is a standard PC inside, and most commonly it runs off-the-shelf Windows with all its vulnerabilities and problems that comes with every other Windows in the network. And as I mentioned, it contains all the connectivities the standard desktop would. So there is a USB, keyboard, mouse, drivers, they are all present on the operating system. Mass storage devices are present. And unfortunately, in the past, there was other options for operating systems. So when I started working in financial industry, I encountered NT4 based ATMs, Linux-based ATMs. They were very common in early 2000s, but thanks to extensions for financial services, it's phased out. So what is this? So as I mentioned, hardware inside ATM is common, but software is usually not. And in the early days, when you get ATM, you get it prepackaged. So it is a box that is configured by whoever is deploying these ATMs, and they contain only software which is predefined by the vendor. So if you buy one ATM, you get it as a whole. So you don't have any options to perform any changes on it. That created a lot of problems. So first, it was really expensive because you're buying everything from ATM vendors. So even Windows license, which you might have much cheaper for yourself, you're paying to vendor. Then software that you install is always a problem because vendor will not allow you to install any software on their ATM because it is all tied in. So in order to address this, these extensions are developed. So it is somebody who was very in love with Java probably had the idea, let's create some middleware to separate software from the hardware. So, and unfortunately, this standard supports only Windows until now. So current standard is about 20 years old. Version 3 was issued in 2003, and that is current version with some minor updates. I think we are at 3.5 right now, being most current, but there are not many changes. We expect version 4 will soon be out, and it should bring a big change that other operating systems should be supported, including Linux. So we hope in the future we should be able to have more Linux-based ATM machines out there. But for now, we are stuck with Windows-based ones, and it will be so for some time. So what these extensions bring? So they are modular and open framework, which is freely available and documented, and it gives, as I said, hardware abstractions using APIs. So using some interfaces which are predefined. So I will go in more details later, but it is interesting to see here. So we have XFS, which goes between actual application that runs on the ATM and the hardware itself. So hardware is here. XFS is split into two parts, one being manager, which has all interfaces between application and hardware service provider interfaces, and service provider interfaces which are created by hardware vendor in order to communicate, to provide proper interfaces and to enable communication with ATM hardware itself. Okay, so this gives a lot of options. So at this moment, our ATM software is no longer strictly tied to hardware vendor, but there is an option to mix and match. So this gives opportunities to install different kind of software on ATM that is controlled by bank or whoever is deploying that ATM. It gives us option to run antivirus, other security suites which supports this interface, and we can finally patch Windows which is installed on the underlying machine. So until that, you couldn't touch it because vendor would not guarantee that your ATM would operate with new patches, and it created a lot of fun. So if you gain access to ATM, it's usually game over very early because there is no antivirus, there is no patching, it's Windows XP mostly. Still, Windows XP, I believe, is most dominating operating system running on ATMs. So based on my experience, I don't know, I didn't count them, but everything that I checked is XP. There are few Windows 7s and few Windows 10s, but mostly XPs are around. So in order to better understand how this all works, I created a very rudimentary example of one transaction that happens at the ATM. So when you approach ATM device, you will see it is running in what we call idle mode. So it will be showing some marketing messages to you, some movies, whatever is predefined by the vendor. And as soon as you put your payment card in the JAWS, it will notify card provider. There is a DLL which is interfacing with this specific card reader, and this card reader gets pulled by the application which runs here. So application will communicate over application API with manager. Manager will recognize what needs to be done and then trigger SPI. This is service provider interface. This service provider interface will call specific DLL which is running in service provider module and actually call specific operations. So in this case, application will ask, oh, is there a card? No. Okay, I'm still in idle mode. Then again, oh, is there a card? No, I'm still in idle mode. Is there a card? Yes. Okay, then ATM switches from idle mode into the active mode. So it will start interacting. You see, hello, please enter your transaction, what you want to do. Do you want to see your balance? Do you want to do some transaction? And then you will start interacting. And in every single point, all communication goes from hardware through XFS and to the application inside the running on the ATM. So then it will ask, okay, enter PIN. Now we enter it on our keyboard. So we enter PIN. Application implements business logic. So application will drive the process. Extension XFS is there to manage communication with hardware. So, and standard, enter your PIN, you enter the PIN. If PIN is valid, enter amount of money to withdraw. You enter amount of money, then application go and check. Are you authorized? Do you have enough balance to do it? Is there enough money in the ATM drawer to satisfy your requirement? If you ask for receipt to be printed, it will query receipt printer, do you have enough paper? And if everything passes, then it will issue one magical command that we like so much, dispense money. So it will say, okay, dispense this number from drawer number 1, this number of money from drawer number 2, because you can have different configuration of this drawer with different value of notes. So you can have 1 notes, 3 different kind of notes in order to give you as close as you need. So if there is no enough, if you put very weird amount of money, it will not be able to process it, because in Serbia specifically you cannot do anything less than 500 dinars, I believe. So in other countries it is, I think, 5 or 10 euros is minimum. So you need to round your transaction to that. But all communication will go from the application through XFS to the hardware using these interfaces. This brings also some important problems. First one is there is no authentication in communication between application and service providers. So DLLs will not authenticate if application actually can communicate, should be able the right endpoint to communicate. It will just execute command which comes through DLLs, and it will automatically assume, since you have access to ATM, you must be authorized to do that. So that's excellent for us, because this gives us good opportunity to, instead of doing old stuff when we did a lot of hardware devices in order to make ATM spit money, now it is enough for us to interface just with XFS. And the best thing, it is exactly the same on every single ATM. So we can develop tool once and reuse it on every single ATM because interface is the same. So on previous slide I have this CVA for cash dispenser interface. So you need to go read it. It's big PDF. It tells you exactly which commands you need to issue to cash dispenser in order to spit out the money. So jackpotting, as soon as you get access to ATM, is relatively easy to do. So in the past, we had to do it differently. So sniffing, analyzing traffic. If it was serial, it was easy because at that time they didn't have any challenge response authentication. So you just need to sniff, capture dispense command, repeat command, and you're done. But you needed to sniff serial communication. Now we don't need to do that. We don't even care how money draw dispenser is implemented. We just go issue few commands in Python and money is there. So easy to go. So what are the actual attack surfaces? So some of them are obvious. So first one being physical. So means that we attack ATM itself. So we go pick up ATM and use different brute force methodologies in order to gain access to money drawers. Not smart, because most of the banks right now are implementing some protections. So like putting bags with paint inside the money drawer, and if it is open without authorization, it will explode, it will paint you, it will paint everybody around you, and it will paint money, so it's useless. And if you go with such painted money somewhere, you will be probably called by police. If you go to bank or any place when you can be recorded, your image captured, or maybe detained at spot. The other option is network. So I already mentioned that network used is more or less standard networking. So I will go later, I have a nice slide, but there are cables around, or there are wireless signals around. Sometimes they are not encrypted. But it's always interesting to do some kind of man-in-the-middle attacks to see what we can get there. Of course, attacks on the ATM computer are standard attacks like any other Windows. They are very rarely on the main. They should be in isolated network. Should be doesn't mean that they are on isolated network. So there are many pen tests in which we discovered ATMs on actual network, either in separate VLANs, but VLANs are routed, so somebody forgot to disable routing between VLANs, and we gain access to ATM which had admin username and password. So it happens. But at that point, when we get access to ATM console, thanks to XFS, it's game over for ATM, jackpotting immediately. So there are also other hardware components. Sometimes everything is protected well, but you can simulate ATM computer by connecting it to your Raspberry Pi. So very recently we had some attacks which involve Raspberry Pi being inserted inside the enclosure and connected in order to do whatever needs to be done. So as I mentioned, physical attacks, this is good opportunity to see that they are easy to break in. They are heavy. So what we like to say, it is for Americans in weight. But strong people can easily move them around, and they do. So they are always positioned somewhere where it's nice for people to approach them, so you have a lot of people. Problem is that they are very rare that they are constantly monitored, because if you have one bank which have like 100 ATMs, they might be able to record all of them, but they will not track every single one of them. In some more advanced cases, what we saw is there are additional sensors, shock sensors which will detect movement, noise sensors which will detect any sound. There are additional cameras saving who is approaching, and they will do motion detection in order to detect that somebody is approaching, then activate the screen. It's possible, it's being done, but it's not very common. So another problem is that ATM enclosure is usually very poorly created. It should be, we always assume that somebody who did this know what he's doing, but unfortunately everybody is trying to cost save. So it is thin, cables are not routed smartly, so sometimes it is very easy to access cables from outside. If you know where to drill, it's very easy to drill housing on specific place and to get access to either USB ports or to network cables, or to some serial connections, which I mentioned already. And of course, in many cases, locks used on external housing are really bad. So this was one specific example when we were able to shim out and this piece of metal. So it was a latch that was just going up and down with proper key. But as you see, there are vent holes. So we just literally put a wire with hook, put it inside, pull the lever, and we have opened the ATM. So it's really not good idea of security. So, yeah, as I said, all this leads to first simple hacking tools that are around. If you go to this link here, you can see good example how these tools are used in order to gain access to ATM. So they are crude but effective. So you just go there with your brute force, pick up ATM, put it on the truck, drive it far, far away. So all your monitoring, even if you have all these advanced sensors and cameras and everything, they are useless because you are not longer there. So you drove your ATM away to some field and you will be using whatever you want. So currently there are other techniques. So there are plasma welding. So they will just go and cut it out to get money drawer. So not to get full ATM, but just money drawer, because what those bad guys want is actually what everybody wants, money. So even me want money from ATM. So after this simple stuff, so let's cover a little bit more interesting approach, and that is network. So this is unfortunately still a big problem, because what we see is that not all ATMs are using encrypted communications. So as I mentioned, it's not uncommon in mall or airports that you will see ATM traffic over Ethernet cables which are not meant for ATM traffic. And it will go because they trust. So airports, for example, they act as big ISPs. So they provide network services to all different businesses within the airport, including ATM machines. And they all share. So you need to go to one store and you might get access to ATMs which are on the airport. Of course, you can get access to many other more interesting things, but I'm not going to discuss this now. And this capture is from one of real engagements. So when we captured the traffic, analyzed the traffic, and we saw that actually full data from MAG stripe has been emitted in plain text over the cable, over the Ethernet cable. Extremely stupid, but it's done. So everything comes to how ATM is configured. There is a way to configure it not to do that. It should be done like that. It's not always done like that. So another interesting thing is using a little bit more advanced tools for hacking networks on the ATM. So this is again from the real attack on ATM. So we discovered this device neatly connected to ATM. So ATM was exposed, not in protected environment on the outside. And the problem was that somebody connected this device. This is the D-Link router, which is a little bit modified, running OpenVRT on it. They removed USB port, and instead of standard USB port, they soldered this memory stick directly inside the housing. They closed the housing, connected it to the power, and then split the network cable in two. So this device was actually acting as pass-through. So it would sniff every single bit of information that went from the ATM to the network. And everything was saved on this flash device. And there was wireless access point running on this router. So they didn't even need to come close to the device. So they would just drive by, connect to wireless, download the data, and go away. There was one more part of this, so I will show that Next, because humans are easiest targets, so this is also from the same thing. So in order to obtain PIN for these devices, they had added keyboard on top of existing keyboard on the ATM, and this device communicated via Bluetooth with that D-Link router that I showed before. So this had everything. So your max stripe data, your PIN device, game over. So this attack is targeting both ATM itself, because it can intercept authorization messages, it can intercept all the cash management messages that goes, logs, transactions, everything, and also target users because it has full max stripe data and pins from your credit card if you use them. So as I said, humans are usually the easiest target because on all devices you can implement some level of security. Yes, in the end, you can configure your ATM properly. You can lock it down. You can install patches. You can install antivirus. You can do everything properly and still be vulnerable to human mistake. Because humans are not machines, so we make decisions based on our risk assessment approach. Still, when we see what happens in the world, that is definitely not something that you need to rely. So, and attackers are very smart. So they come with stuff like this. So they would put keyboard overlaying the keyboard. So when you type, you will not see anything weird happens. So because if you look, there is all keyboard is still under there, and there are pins. When you push the number 6 on fake keyboard, these pins will push number 6 on real keyboard. So everything just works as you expect. You will get your money, and then you will come home and you will see a lot of money is removed from your account. Of course, as I said, there are other options. So there is on ATM, there is also a skimming. There are devices that you can put on the mouth of the card reader. And this can be very small. It's usually virtually done, but from the point of user, you cannot, if you don't know this ATM and you were not before, you might think this is just a normal thing that is installed. So there will be some plastic, and you put your card, it will read your card, ATM will read your card, do everything, but they got your data from the skimmer. Sometimes you don't need the skimmer. If ATM is not configured properly, it will just go in plain text in the network. There is, yes, one more interesting attack to the users is a different kind of loops or traps, however they are called. How it's done. So in the place when you are collecting your card, they will put a small piece of wire. So you can put your card in, but you will not be able to pick it up, to take it out of the machine. It will not be stuck in ATM, because if ATM swallows your payment card, it will put it in drawer safely. If that is not the case, it will be stuck there. So they can come and pick it up with small tools like screwdrivers or something. They can remove this and take your credit card. And of course, they will already have your PIN. There is another attack which do the same, but on the money drawer. So you will go in, you will pick up money, but there will be no money out. You might try to call help center to see where is your money, what's happening. Money is there. While you're not looking, they will come and take your money outside of ATM. Problem is how to protect. So you need to be very vigilant and helpful. There are some applications, for example, that can scan for Bluetooth traffic. So if you see that your ATM emanates Bluetooth connectivity, suggestion is go away from that ATM. If there are weird Wi-Fi access points, it's not definitive, but it is something to be suspicious. There is one last thing that is not proven, but I believe I saw this with my own eyes, and that is rough ATMs. So what happens? Normal ATM is removed and taken to service or whatever, but there is empty place. The guys went and set up copy of ATM device, which looks exactly normal, but just don't work. So whatever you do, it will just throw you error. There is no money in drawer, your transaction is down. Problem with that is you need to tick and make sure that it is real, sturdy ATM, not normal. Or you can do something like this. So yeah, I think there are better ways than employing this nice girl to protect you, but hey, maybe this is a way to go. So that would be all from me. Thank you. Questions, please? Questions?
I've seen some ATMs have the contactless ways of paying and like authenticating. Is there a way to abuse that functionality? Like,
whenever there is something that does not require authentication, there is always a way to abuse. So there was all joke that, again, I have not verified myself, but there was attempt to do it by using 2 coils, not on the ATM, but in the shops. So you would be waiting in the shop. Somebody would go with 2 coils. 1 coil will touch your purse, 2nd coil will go to POS device. They say it works. I haven't seen it myself, but everything can be abused if there is no authentication. Usually banks enable this as a favor to you, so you don't have to type your PIN for small amounts. So risk is small, but it's never zero, so it can be exploited. So if somebody takes your card, it can use it to pay for small amounts without any authentication. So you don't have protections of the PIN.
okay, thank you.
Just one more thing that you said about the wire, that it swallows the card, and sometimes it's stored in the inside of the ATM, and sometimes it just gets stuck in it. Since the keys for the ATM can be bought on the Alibaba or AliExpress or any Chinese web shop, you can still use the key and open the machine and take the cards from it. So if your card will get swallowed, always block it, since anyone can access the ATM if it's standing outside on the street or somewhere where it's not protected, and they can still access your card and steal it, even if it would be like protected by the ATM. So just always block your card, even if it's if you see it's swollen in the ATM.
Yeah, thank you for that. So that's good. So yeah, most of the tools are available to buy for cheap in your favorite Chinese shops. And unfortunately, a lot of service manuals for ATMs are available to be downloaded off the internet. Some of them containing tech user passwords in them, which are not changed and can be used again. So that's unfortunate. Not just for ATMs, but unfortunate state of security for everything.
You said that most of ATMs are under Windows XP, and that's true, but it's not a problem in Windows XP if that ATM and Windows XP is hardened, all services that are not needed disabled, all physical USB devices removed, only for dispenser, and the I think higher risk and issue is attaching the other device like Raspberry Pi or some other device that will send commands to dispenser to spill the money, and protection of that is routing of the cables. So when you try to physically cut the ATM, it's built on that way that the places where you really want to arrive are protected on adequate way. So it's not really easy. There is you show examples where they are under some door and really bad implemented. But if it is implemented as it should be, then you really need to know where you need to cut the metal, and it's really difficult to attach devices. And you didn't mention there is also one really popular attack with the gas, with explosive gas, that they fill the ATM and explode and pick the money, whatever they can get after explosion. So
Yep.
that is even in Serbia was active attack, and the case with the fake ATMs happened in Belgrade, but it was, I think, decade ago or something like that. It was purpose for harvesting payment cards. So they put it on, just came with the truck, put ATMs and wait few days and get out with the card information. So it's really easy to scam the people, because people need an ATM, see on the place, let's use it and leave the data. Okay.
Okay, thank you.
Hi. What about the contactless reader?
We have that question already.
I missed
So,
it.
contactless reader is just reader, so you can put other contactless reader on top.
We usually, look for the skimmers and etc. Huh?
It can be. So if you see, so there is some ATMs which are normally flat and they don't have. So it's easy to put just big plastic piece that will just do everything for you. So yeah, problem is interfacing that. So it would require a little bit more work, but it's not impossible. So everything can be hacked. That's period. So yes, it can be protected and hardened, but there is always a way. So it's already mentioned. So it's cat and mouse race. So whatever attackers think of, there will be somebody who will think how to defend. Then attackers will again find new ways to win. So it's.
Have you seen blue screen of death and jackpotting, and how often?
Sorry.
Have you ever seen blue screen of death on the Windows crash,
Yes.
and how often? And the jackpotting as well.
Jackpotting is unfortunately very common. Whenever we do pen test on ATMs, there is a jackpotting. So I have never done it on real ATM, maybe once, but it was again during the pen test. But I have not seen, I'm not in that area. So my job is to test for security, not to chase. But blue screen of that is not uncommon, so we saw it on few ATMs in real life.
I saw it once in real life.
I work for the bank, I saw a few more. Welcome. Okay, I think we should stop the questions now to give chance for other speakers to prepare. If you have any further questions, I will be on the hall so we can continue discussion. Okay, thank you all very much.